All right, good morning, everyone. Welcome. Today we are going to be doing chapter 6, lesson 4 about taking nth roots. So this is going to be the same idea as like a square root, but a square root would be the second root. So n would be 2, a second root. We're going to be taking third roots and fourth roots and fifth roots and sixth roots, that kind of idea. So an nth root is the inverse operation, or the operation that undoes taking something to the nth power. So like the third root undoes taking something to the third power. The square root undoes taking something to the second power. Those would undo each other. They're inverses. The index is this little number right here that we're going to put in the front of the radical. If you don't see any number at all, like this right here, it is a 2. I know in math you've become accustomed to if you don't see a number, it's an invisible 1, but you got to be careful for these indexes or the indices of a root. For those radicals, if there's no number, it is a 2. It is a square root. The last vocab word here, the principal root. Not going to talk about that too much, but you might see it written on a standardized test, like an SAT subject test might ask something about it. The principal root is just the positive root when you do an nth root if n is even. The reason why it's only when it's even, we've talked a lot about the square root of 4. If you solved x squared equals 4 by taking the square root, you have to say that x equals both positive and negative 2. Whenever n is an even number, you have to take both the positive and negative. The principal is just the positive version. All right, so this says for any real numbers a and b and any positive integers n, it says if a to the n, where n is a positive number, if a to the n is equal to b, then a is an nth root of b. So it says because negative 3 to the fourth is 81, negative 3 has to be a fourth root. And then right here, like I said, the principal root is just the positive version. If that definition is a little confusing right now, I think it will make a little bit more sense once we get into some of these examples. You'll see what we're talking about and how these roots are working out. All right. This right here is just a little chart to think about. It says if n is an integer greater than 1 and a is a real number. So a is any real number, and then in this first row here, it's a positive real number, so any positive number. If we take an even root of a positive number, we're going to have one positive and one negative real root. Just like if we took the square root of 4, would have both a positive and a negative root. This is a positive number. A is greater than 0. Our index n is greater than 1. It's 2. So n2 is even. We get positive and a negative. If n is odd, if we're doing like maybe the third root, we're not going to do the third root of 4, maybe the third root of 8. The third root of 8, what number times itself again, gives us 8. 2 times 2 is 4, times 2 is 8. So the third root of 8 is 2. Now we cannot put both positive and negative, because if you did negative 2 times negative 2 is positive 4, but then positive 4 times negative 2 would be negative 8. So you're just going to have that positive, no negatives. If a is negative, and you're doing an even root, you're going to have 0 real answers, because you can't do a square root or a fourth root or a sixth root or eighth root and get a negative, because you're always going to have either negative times negative or positive times positive, and you're never going to get a negative number. So if n is even, you're not going to get real answers for negative numbers. If n is odd, it is just fine to get a negative number. Like we could do the third root of negative 8, and that is going to be negative 2, because negative 2 times negative 2 times negative 2 would give you negative 8. And right here, if you are just taking a root of 0, it doesn't matter what root it is. Any root, second root, third root, fourth root, fifth root, sixth root, seventh root, eighth root, no matter what, any root of 0 is just 0. Again, I think this will make a little bit more sense once we start into some more examples. So here is an example. There's no index here, no number, so it's a 2. You don't see it, but it's a 2. So we have the square root of 16. Well, we've done the square root of 16 before. That's just 4 plus or minus is, we're just dropping the plus or minus down. Square root of 16 is 4. And to do the square root of x to the 8th, x to the 8th could be written as x to the 4th squared. Remember, our power of a power says 4 times 2 would be x to the 8th. So we have the square root of x to the 4th squared. The square root and the squared cancel, leaving us with just x to the 4th. A little shortcut you can use for taking roots of variables to a power is just divide the exponent by that index. If you did 8 divided by 2, you would get 4. So there's our answer, plus or minus 4x to the 4th. Right here, again, we don't have an index. There's nothing here, so it's a 2. So to do the square root, or there's the opposite of the square root of this quantity, p to the 3rd plus 5, that whole thing being raised to the 4th power. Again, we have a whole thing being raised to a 4th power under here. So I can just take that 4th power, 4 divided by 2, gives me 2. So I have q to the 3rd plus 5 in parentheses. It was to the 4th. 4 divided by 2 gives me 2, so it's squared. And the negative sign just drops right down. So we have the opposite of q to the 3rd plus 5 quantity squared. If we wanted to change that, we could write q to the 3rd plus 5, q to the 3rd plus 5, FOIL it out, see what we get, but we'll just leave it right here. All right, this one asks us for the 5th root of 243, a to the 10th, b to the 15th. Again, our easiest way to handle this a to the 10th, b to the 15th is to just do 10 divided by 5 gives me a squared. 15 divided by 5 gives me the b to the 3rd. Now we just need to do the 5th root of 243. So again, we have to think what number times itself 5 times is going to give us 243. So if you tried 2, you'd have 2, 4, 8, 16, 32. That doesn't work. If we tried 3, we'd have 3, 9, 27, 81. 81 times 3 is 243. So the 5th root of 243 is 3. The reason for that, again, is because 3 times 3 times 3 times 3 times 3, that does equal 243. That is just something that you'll kind of have to learn some of those roots. We'll talk about that and give you some information to help you out shortly. All right, here we have simplifying the square root of negative 4. There's, again, no index, so it's a 2. The 2nd root of negative 4, there are no real roots, but we've done this before, we could take the I out. That's the square root of the negative. Square root of 4 is then 2. And we could have our plus or minus. All right. Here we go. Plus or minus the square root of 9 x to the 8th. Again, no index here, so it's a 2. Square root of 9 is 3. X to the 8th has to be 8 divided by 2 gives us 4, so that has to be our x to the 4th, and our plus or minus drops down. Plus or minus 3x to the 4th, plus or minus 3x to the 4th. Right there is b. Can't see, looks really close, but there's no plus or minus. The plus or minus has to drop. Right here, our negative is just going to drop down, so I can get rid of c and d right away. And again, no index, so it's a 2. The 2nd root of this, something in parentheses raised to the 8th power, I do 8 divided by 2 and I get 4. So I need that exact same parentheses raised to the 4th power. So that exact same parentheses raised to the 4th power. A is our answer. Since it's grouped in parentheses being raised to the 8th, we do 8 divided by 2, or 8 divided by our index, in this case 2. And there we go. Alright, on this one, we're doing the 5th root of 32, x to the 5th, y to the 10th. To do x to the 5th, 5 divided by 5 is x to the 1st, or just x. 10 divided by 5 is 2, so y squared. So I have to have an xy squared, so that's out, xy squared. That's out. The 5th root of 32, 2, 4, 8, 16, 32, 2 times 2 times 2 times 2 times 2, 2, 4, 8, 16, 32. So the 5th root of 32 is 2. Now, do we have plus or minus, or just the plus? For a 5th root, when that's odd, we cannot do plus or minus, because negative 2 times negative 2 times negative 2, if we type that in, negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 5 of them, gives us a negative 32. When it's an odd number, you do not get the plus or minus. So it has to be A. Alright, here we go. We are doing the 6th root of t to the 6th power. So just like before, we're going to take the 6th root of t to the 6th. We have a variable raised to an exponent, and we're doing a root of it. So we do our exponent divided by the root. 6 divided by 6 is 1. So we just get t. Now the problem is t could be positive or t could be negative. So since it was an even index on here, since the index is even, we want to write our final answer as the absolute value of t. Because if t was negative at the beginning, our answer, our 6th root of t to the 6th, is still going to be a positive number, even if it was negative. Because if you took a negative number to the 6th power, it became positive. When you took the 6th root, it stayed as positive. So this is going to simplify down to being the absolute value of t. It's always going to give you a positive number, whether t was or wasn't positive. Again, the reason why we need the absolute value is because our index right here, 6, is even. For this example here, we don't need any absolute values because our index is odd. Since our index this time is 5, odd, we don't need to worry about absolute values. So we find the 5th root of 243. We already talked about that one. It's 3. Again, that's because 3 times 3 times 3 times 3 times 3, 3, 9, 27, 81, 243. 3 times itself 5 times does give you 243. Then we have something in parentheses being raised to the 15th power. 15 divided by 5 is 3. So we have an x plus 2. 15 divided by 5 is 3. So 3 x plus 2 to the 3rd. No absolute values needed because that index is an odd. So if x plus 2 to the 3rd happened to be a negative number, when you multiply by 3, it would stay as a negative number. We are not switching anything because everything there is odds. Alright, here we go. X to the 4th, 4 divided by 4 is 1, so just x to the 1st. Since our index is even, we need our absolute values, so it has to be C. Since that is even, we need absolute values. On this one, our index is an odd number, so no absolute values needed, so we can get rid of those. The 3rd root of 27, 3, 9, 27, so the 3rd root of 27 is 3. X plus 2 in parentheses. 9 divided by our index is 3, so 3x plus 2 to the 3rd. Our answer is B. You divide the power by the index, not subtract. That's where that came from, subtracting. That's not right. You divide. All right, right here, just a little application problem. They give us a formula for how long it takes a pendulum to swing back and forth. It tells us that G is 32, so just plug 32 in there. And it wants us to find the value of t, so t is equal to 2 pi, pi is a number we know, the square root of L, 2 foot long pendulum, so 2 over G is 32. So this is just typing things in your calculator. So I'm going to do 2 divided by 32. That square root is a grouping symbol, so we have to do that first. we do the square root of that answer. Gotta find the square root button on your calculator. Multiply that by 2. Multiply it by pi. There's my pi button. And I get right about 1.57. So B is our answer. All right. Now, there's going to be some questions on here approximating nth roots with a calculator. So if we want to do the 7th root of 18, that's a problem because 18, there is no number times itself 7 times that gives us exactly 18. So to get an approximation or a roundabout, we have to do 18 to the 1/7 power. We'll talk more about why that works in future lessons, but in my calculator I do 18, use your exponent button, and then in parentheses 1 divided by 7. The 7 is because that was my index. You do 1 divided by whatever the index is. So the radicand to the 1 divided by index power. In this case, that's right around 1.51. For this one, we want the opposite of the third root of negative 168. Since it's the third root of 168, my radicand is 168 to the 1 divided by 3. And that gives me right around 5.52. That negative drops down. And then to do the third root of negative 5, I can do negative 5 to the, in parentheses, 1 divided by 3 power. Some of your calculators are not going to like doing exponents of negative numbers. It should work out just fine. But if your calculator doesn't like it, just put it in as 5 to the 1/3 and then add in the negative yourself. But that rounds off to negative 1.71. Just rounding those off. Typing them in your calculator, rounding them off. And this last one is your assignment. Have this ready to go for Tuesday. Let me know if you have any questions. Bye.